threw this one together as I walked around about half. Looked like they had it. The answer is 57.9. Is that what we had? 57.9. So if you did not have it, just let's review. The first thing to do is balance the equation. So it's 2, 1, and 1, right? Sound good? All right, so let's set this picket fence up. So I gave you grams of F2. Are we okay with that? So the unit down here has to be grams of F2. Anytime we find grams, it's per what? 1 mole of the same substance, which means what unit is down here? Right, moles, F2. I need another line right there, correct? All right, and then I come back over here. What am I solving for? Grams of HF. That means that the end is grams of HF. And anytime I find grams, it's per what? 1 mole of the same thing, which means I put mole HF right here. So I'm a little confused how we got it right. There's a little bit wrong in the thing, but we'll look at it. So what do we have for mole of HF up here? A 2. What do we have for F2? A 1. We come over. What's the grams of HF? 20. What's the grams of F2? 38. Now, a lot of people just put 19 right there, but remember, it's diatomic, so we count both of them. And then we're ready. 55 times 2 times 20 divided by 38 is almost 55 divided by 55, to be honest with you. And we said it was 57.9, right? All right, who had that right? Raise your hands. Keep them up for me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 14. That's not awesome, but it's not a disaster either. Okay, by the end of today, we're hoping that you pretty much know how to do all of these, or that you can at least battle through and figure out most of them. Sound all right? Okay. Today we're going to go moles to liters. So if you'll take out your periodic table, let's talk about moles and liters. Let me borrow that one. So whenever we were together last, we talked about this map, right? We said this map, if you know where you are and you know where you want to get, it will tell you how many steps to take. Does that sound familiar? Okay, we're going to add a couple things to this. They're just little, but look right here. Hopefully you'll notice the word liter right there and liter right there. Those are not written in yours, so will you write them out? It says volume, which the unit of volume is liters, but we're just putting that so on a test you don't forget your brain. All right, do we all have that? Will you remind your lab partner what this line was for? Ready, set, go. Okay. The most repeated word I heard from you was the word cross. So we have to cross this line to at least cross that line for the answer to be, or for the problem to be worked out, right? So here we go. When we go from moles to liters, please look up here. From moles to liters, we start with moles. And where are we going? Liters. Would you go up there? No, you got to cross. And it is my advice that you always cross right there. I would not cross here or here. I would always cross in that middle. All right, so I've gone from moles, I've gone across the line, but I'm at moles. But this problem's asking for what? Liters. So how many arrows is that? That's 2, which means my picket fence will have 2 vertical lines. Are we all right with that? Okay, This is a new thing to you, and it's very important that you see it. That is a ratio that we're going to use in a picket fence anytime we are finding volume. So it says there are 22.4 liters, and I would add one little part to that. 22.4 liters for every, I would put a 1 in front of it, 1 mole. This is a ratio we're going to use anytime we use volume. And remember, we can certainly flip it over if we need to make the picket fence work. So don't think that the 22 always has to be on top. It will go wherever we need it to fix the problem. We okay with that? Okay, so let's come back. And will you please balance this problem? It's right there in your lab book, in the notes section. I think it's page 11 or 12. We've been on forever. Thank you. Here we go. So combustion reactions, we've done 1,000. You're going to do at least 2 on your test. So you start with a 2. That's a 2, I promise. And then you balance the carbons. 2 times 3 is 6. Then you take the 8 and put it in front of water. Then 6 times 2 is 12. Plus there are 8 more. That's 20, which makes this a 10. Feel like we've balanced this even 3 or 4 different times. Sound right? Okay. Now, I don't have the problem written up here, but it says something important. I have it. It says if you have 50 liters of oxygen, so we're going to follow the process so we don't go astray. Bueno? All right, the process means you start with the number and unit I give you, which is what number? 50. I got to move this down here. There's no way it'll fit right there. So just be patient. We have 50 liters of what chemical? O2. What am I solving for? All right, moles of propane. Okay, and once again, from my map, how many vertical lines did it have? 2. So here we go. Look at me for a minute, unless you already have it figured out. What unit has to go down here? Liters of O2. And from my picket fence, or my periodic table, what is the ratio? Chemistry A or B? Yeah, they're right there. That is them. Okay, so from that periodic table, you got it. What's that ratio? How many watts per what? All right, 22.4 liters per, always. 1 mole, and the chemical always has to match, O2 and O2, which means what has to go down there? What about it though, Alec? Mole of O2. Now, we don't know what would go next except for the unit at the end is the unit at the end, mole, C3H8. And then we go to our balanced chemical equation. It's a 2 for the C3. It's a 10 for the O2. So I'm going to reduce that. So it's a 1 to 5 ratio. Are we okay with that? Thank you for being okay with that. So now, a lot of people, math-wise, screw up in their phones. This is 50 divided by 22.4 times 5. If you're using your phone, I would write them out. I would say, all right, I have 50, and then I would multiply 22.4 times 5. That's going to be around 112, okay? So it's 112, and then I would divide them. Because some of you are not good at math on your phone, and when there's 2 numbers in the denominator, you screw up a lot. So if you're using your phones as a calculator, which you can't do on the test, so bring a real one. Anyway, type it or write it out and then divide it. So 50 112ths is probably around 0.6. No, sorry, 0.4. What is it? 44. Okay, will all of you type that in and see if you get 0.44? Not the 50 over 112. Do that how you would normally do it. Then, once you're done, double checking that, I want you to look at number 48. That's the one in the homework I'll help you with because it's the hardest one. So first thing first, will you try to balance number 48? I wrote it out for you. It's the very bottom of page 15. So write out and balance number 48. Now let me walk you through how I already wrote this out. This is a metallic chlorate. The problem says, it might even tell you, I don't know, let me see. If calcium chlorate is heated, it decomposes. So it even tells you the two parts. But if it didn't, you would go to your naming schematic and find the rules for what happens with metallic chlorates. And it will say metallic chlorates, when heated, decompose into metallic chlorides, meaning just Cl's, no oxygens, plus then oxygen all by itself. Okay, now this problem says it goes to calcium chloride plus oxygen, but if it doesn't, and there's one like this on the test, there's no math to it, but you have to decompose and balance it. Make sure you follow those decomposition rules. All right, balancing these sometimes are hard. This particular one I don't think is very hard, but if it was to you, that's fine. In a decomposition reaction, you have to balance each part individually because they break up. So how many O's are there? There's 6 of them. How do you make a 3? Okay, I gave that away. How do you make a 2 become a 6? You put a 3 right there, right? And then, if you'll notice, there's 2 chlorines, and there are 2 chlorines, 1 calcium and 1 calcium. So it is 1, 1, 3. Now, the reason I chose number 48, and I'll let you do the rest yourself here in a second, is it's moles to liters, but it's backwards of the ones we just did. So if you look at 48, if it is heated, how many liters of oxygen? So, well, I guess it is the same as we just did, so never mind. We're going to end here, there, and there. Sorry, I thought it was backwards when I read it this morning, but it's the same. So go ahead. How many total steps are there? How many arrows? 2, Mr. Davidson. That's right, Mr. Davidson. All right, try that out yourself for a few minutes and work through this together. If it was a struggle, that's fine, but please try to recognize the process. How many liters of O2 can be produced from 34 moles of calcium chlorate? So we take and put, so it was backwards, whatever. I don't know, I'll shut up. 34 what's? Moles of CaClO3 2. So what must go down there then? What unit? Mole. CaClO3 2. All right, I do not know what goes there yet. There's nothing that tells me. So I go to the end and I work my way back this way. So this is backwards. We are solving for liters of O2, right? All right, the unit at the end is always the unit at the end. At any time we're using liters, it's always what number? It's kind of nice. It's always the same number. 22.4 liters of O2 for every what? 1 mole of the same thing. So what unit has to go up here then? Mole of O2. And now we're ready to go. We find that there are 3 moles of O2 to every 1 mole of calcium chlorate. And then we're ready. 34 times 3 times 22.4. It's going to be a big number, right? Yeah. I don't know. What is it? 2284. many of you had it right? Raise your hands. Did you get the right answer? Did you just have the first one as 22.4?
Well, what I did 34 moles, and I carried the moles down, and I did 22.4 liters of CaCl2 over 1 mole, and I brought that down to liters, and then I brought the liters over 2.
That's fine. Like, same thing, blacker. It's a little bit different, but if you get the right answer, I couldn't care less. All right. The next two on that page are above it, 46 and 47. 46 is a combustion reaction, so it can follow those steps. 47, kids ask me all the time, 47 is a composition reaction. Which one's first, SO3 or H2O? SO3. So this is number something right there, plus H2O. And it says they combine. And that tricks some kids up. I don't really know why, but it just makes H2SO4. They literally just go together 1 to 1, and it is balanced 1, 1, 1. This is the production, if you've ever heard of it, this is the reaction that produces acid rain. This stuff comes out of like power plant waste, comes out of your tailpipe, comes out of diesel gas. It goes and reacts with water in the atmosphere to produce sulfuric acid. Anyway, that's the chemistry on number 47. You take about 5 minutes to see if you can do those two problems. If anyone needed help on number 47, that's the setup. Once you have it set up and done, if you want to look and see if you got it right, feel free to do so. You can check with your lab partner if they have it right and you don't, see if they can help you out. And then 46, and then, I don't know, about 3 minutes we're going to move on to how to do the next kind, which is, if you're with me now, they're not hard at all. You just do the next step. You wait till you meet in the middle and you're golden. All right. Let's go back to your notes. We'll talk about grams to liters. So if you'll look, just real quick here, grams to liters, we have been going from moles to liters, which was how many steps? 2. So look at the screen. We're now going to go from grams to liters. We're going to go over, over, and up. So what's our picket fence going to look like? 3 vertical lines. Now, please look. It is also possible that you will be asked to go from liters to grams. You should go down, over, and over. So they're both the same. They'll just be backwards in the way that you line things up. So first thing as always, please balance. Lithium plus oxygen goes to lithium oxide. It won't take too long to balance that one, I hope. Is this one of the 212s, isn't it? You guys are a barrel of fun today. There are 2 lithiums, so put a 2. All right. Oh, wait, I better start somewhere else. We got to fix the oxygens, right? So if I have 2 oxygens, I better put a 2, so I was wrong. 2 times 2 is 4, and then 1 and 2. Sorry, that's why you were looking at me weird. All right, then we read the problem. This problem says, this is on page 11-ish, right? It says if 23 grams of lithium are reacted, so please just look, 23 grams of Li. What do I know goes down there right off the bat? Grams of Li. What do I always know about grams when I find it on my periodic table? Thank you. It's per 1 mole of the same thing. If this unit is here, what unit goes there? Mole of the same thing. But then I'm stuck. There's nothing that tells me what to do next. Now, some of you know by now what goes next, but a lot of you still don't. So if you get stuck, you go to the end, and you're solving for liters of which one? O2, right? It has to be O2. And then if it's liters of O2 at the end, then the end of the picket fence on the top has to match, and it's liters. And what number do we always use when we use liters? 22.4 liters of O2. And whenever we have liters, it's always tied to what? 1 mole of the same substance. All right, so we come up here. This is mole of O2, so the unit here has to be mole of O2, and then we're ready to fill in the numbers. So in front of O2 was a 1, in front of Li was a 4. You okay with that so far? Then we come over from our periodic table. When we find lithium's box, it has a 7 and a 3. We care about the big number, so we put a 7 right there. And then we're ready to go. 23 times 22.4 divided by 7 times 4, or 28 in the bottom. Will you type that in and see what answer you get? If you're like, what's the process? Well, you put the units, you always line them up until everything cancels out, until the unit that you want in your answer. That's what we've been doing this whole time. Every single time, we're lining up the units so that they cancel out. All right, let's turn to your homework and do one together. So this is the back page. That always feels good when you're on the back. So the first thing first, do you want me to do the hard one? Well, there are no hard ones. But I'll do 51. There's no space for 51. Do it at the very bottom, I guess. So it says, oh, it is recording. All right, here we go. It says hydrogen and chlorine react to form hydrochloric acid. Is that what it says? Or hydrogen chloride gas, one of the two. All right, hydrochloric acid is HCl. And then you would balance it, which is just a piece of cake. It's 112. This is exactly like the one we did to start, like the practice one. And then we just fill it in. Let's look. We are going, if you react 6 liters, so we're going to go from liters to grams. So it's still 3 steps. I'm going to start with my given. I'm going to end with what I want. I said liters to grams, right? So 6 liters, was that right? Which one was it? 6 liters of who? H2. And what am I solving for? Mole or grams of which one? HCl probably, right? Okay. Take 2 minutes to try it on your own, and then I'll do it with you. Let's do this one together. So if you need to get rid of liters, whatever, you take this unit right here and put it down there. Liters is always 22.4 liters of that chemical per 1 mole of that chemical. Then whatever unit is here always goes down here, so mole of H2. Then there's nothing directly that tells me what goes in this box, so I come from the end. I know that grams of HCl is at the end, then grams of HCl must be at the end. Anytime I find grams in a picket fence, it's always per 1 mole of the same substance, HCl. That means the unit here is the unit there, mole, HCl. And then I'm ready. If you add these together, they are 36.5. Then over here, there's a 2 in front of HCl. There's a 1 in front of H2. And then I'm ready. 6 times 2 times 36.5. So I don't know. Divide that by 22.4. When you do that math, what do you get? 19.6? Not good, Moyle? Or is that? What'd you get? Who had 19.6? Okay, it's definitely right then. Okay. Are we all right with this idea? The only thing we're finding now is the mass. When we need mass, it's either on top or on bottom, depending on where my units force me to be. Number 50, H2O and then an arrow. It's not too hard. If it's just 2 chemicals and then an arrow, the only thing it can do is break up into the 2 chemicals, right? So it's H2 plus O2. This is the reaction that forms water. This is the reverse of it. So this is actually called electrolysis. We use electricity to separate water into its parts. Okay. Have at it. There's like 5 minutes left. See if you can get those done. So tomorrow that leaves us one last sliver that's actually the easiest of all of them. And it leaves us 2 pages of quick notes that are called like reaction basics or something like that. We are testing on Thursday. So hopefully you're ready. If you're missing any of this, if you missed a day or you can't remember something, the videos that I've been recording in this class are on this page, which you can get there by going to behsscience.com. Then you click on chemistry, and then underneath it has this chemistry live update page. And then here's the first day I taught this. Here's the second day I taught this. This is the area where today's link will go from this recording. I'm making it this second. You can watch those again. Also, lower on this page, it's going to be hard to be precise here. Tutorial videos for stoichiometry. There are 9 of these YouTube videos from me that will help you with individual parts on how to do this. So there's probably 4 hours, maybe 5 hours of stuff on the internet you can watch from me to help you pick this up if you need it. Okay?